Example G. First, let's think of f of x being the function x over 8, which could also be seen as 1/8 times x. So when you take the derivative, knowing that the value would just be 1/8 is easy since the x turns into a 1. So it's kind of like our function x over 8. The derivative, if we just took the derivative of x being a 1, then we get that 1/8, which is the same answer. So what I'm saying, if x is the only variable for a derivative and it's in the numerator, then we can go ahead and just take the derivative of the x and leave everything else as is. I mention that because we're about to do that exact same thing for this problem that looks like it could take a quotient rule, but we're only taking the derivative of x, and x only shows up once in the numerator, so we do not need a quotient rule. We'll just let that x turn into a 1 and leave the denominator as is to get a final derivative of 2 over 4y plus 3z. Now we go to take the partial derivative of y. Y only shows up once, but it's in the denominator, so we don't necessarily need a quotient rule because it's not in the numerator and the denominator, but in the denominator as being part of a binomial, then we do want to use the quotient rule. That will just make things easier. So we're going to treat the numerator as our f function and the entire denominator as our g function. So according to the quotient rule, we start off with f prime, which for us is the derivative of the numerator. Since we're taking the derivative about y, and there is no y in the numerator, the derivative is 0. Then we multiply with g, the denominator in its original form. Then we subtract, where we copy the numerator, or f, as is. And now we're going to take the derivative of the denominator only looking at the y variable. So the 4y will give us a 4, but the 3z is gone because there was no y in that piece. And we finish by writing the denominator squared. And now I just need to clean this up, where 0 times anything is just 0. But I can multiply my -2 and my 4 so that I have -8x all over the binomial 4y plus 3z quantity squared. And on to the last one, the partial derivative of the z variable. Again, we're going to go ahead and use the quotient rule because even though z shows up once, it's part of a binomial or a multi-term polynomial in the denominator. So f prime being the derivative of the top, there is no z, so it's 0. The denominator as is for our g term, minus the original f, even though there's no z, we're just copying the f function. But now when I take the derivative of the denominator, I'm looking at z. 4y goes away, but 3z will just give me a 3. And again, over the denominator squared. Last time cleaning up, again, we have 0 times a term, so that piece drops off. And again, -2 and +3 can be multiplied to give me -6x over the binomial 4y plus 3z quantity squared.